Yes, teacher.
Yes.
I think we are together.
Yes.
Very good. So I don't want to leave anyone behind, the members. I don't want to leave anyone behind here. So that's how we get logarithm for numbers which are what? Greater than?
Than 10.
Greater than 10. Let's go ahead and see. Logarithms, subheading, logarithms of numbers between what? Between 0 and 1. Between 0 and 1. We say logarithms of numbers between 0 and 1 can be found from tables. From the table of logarithm by first expressing them in standard what?
Standard form.
It's like getting also, it's the same also for numbers greater than 10. So we do the same. We first express numbers in standard form. So express the given number. Express the given what? Number in standard what?
Standard form.
Standard form. In standard what? Form. Then after that, read the value from the what? From the table. But I've told you the technique now. You can either use the log table or you use your
calculator.
The only difference is from the log table, they are expressed to how many decimal places? To 4, not so?
Yes.
So to confirm that you have used a log table, even if you have used a calculator, just write your answer to how many decimal places? To 4. It will still give you the same value. Are you together?
Yes.
So don't worry whether you have a table there or not. Don't worry about that. Okay? As long as you know how to express, you know how to press it in your calculator. So let's go to examples. A, they want us to find log to base 10 of 0.723. 7 what?
723.
So we said we start by what? 0. We first start by expressing the number in standard form. So what is this one in standard form? So this one is going to give us what? Negative what? Negative powers, not so?
Yes.
Yes, if you remember how we express standard form. So it's going to be 7.23 times 10 to the power negative 1. Negative what?
Negative 1.
Negative 1. Because we have moved only, we have shifted the position of the decimal point by only one step. Okay?
Yes.
So we shall have log to the base 10 of 0.723 equals to log to the base 10 of 7.23 times 10 to the power negative what? Negative 1. So when you split that one further, you give 10 to the power 4, which is the same as, it's going to be 7.23 plus log to the base 10 of 10 to the power negative what? Negative 1.
Negative 1.
So pick your calculator. So you read 7.2 under what?
3.
If you are using
under
a table,
3.
If you are using a table, you read 7.2 under 3. If you are using a calculator, just press log of 7.23. Okay?
Yes.
So what do you get? You get
0.8591.
8591 plus negative 1.
Negative 1.
Negative 1. So what do you get? So this one is the same as, it's going to be 0.8591 minus 1. Not so?
Yes.
So what do you get?
Negative 0.1.
Negative 0.1.
Negative 0. Negative 0.
1.
4.
0.
09.
1 4
409.
09.
9.
Are you together?
Yes.
But in logarithm, we don't write the negative like this. In logarithm, we write it as a bar. We write the negative as a what? And you write it only on, I said this one is called what? What is this one? This one is called what?
Characteristic.
You put the bar on the characteristic if it's a negative. So you write 0 bar, like that. That's how we write it in logarithm, okay?
Yes.
0.1409. That's how we write it in logarithm. Members, have you seen it?
Yes.
And the negative is only for the what? Is the negative is for?
The characteristic.
Yes, it's not for the mantista, okay?
Yes.
So you press that one direct in your calculator. Press for me log of 0.723 in your calculator. What do you have? What do you have?
Negative
Negative 0.140.
Negative 0.1409.
9. Good. Good. B. Let's look at B. In B, what do we have?
9.
Is 0.0052. Okay?
Yes.
So they want us to find log to base 10 of 0.0052. But 0.0052 is the same as 5.2
5.2.
times 10 to the power
Negative 3.
1, 2, 3 to the power negative what? Negative 3.
3.
So log to base 10 of 0.052 is equals to log to base 10 of 5.2 times 10 to the power negative 3.
Negative 3.
Split them. So you have log to base 10 of 5 point what? 5.2 plus log to base 10 of 10 to the power negative.
Negative 3.
So press for me log of 5.2. Log of 5.2. What do you get?
0.7160.
160 to 4 decimal places. Don't forget that should be your sum. 4 decimal places plus negative what?
Negative 3.
So this one will give us 0.7160 minus what? 3 if you follow the law of integers. The law of what? Integers. So what do you get there?
Negative 1.
Negative
8.
I said, how do you write the negative? You said 1 bar. Okay?
Yes.
Point?
0.28.
28. 28?
Yes.
28 what?
39.
39. Press it direct. Press it direct in your calculator. Press for me log of 0.0052. Do you get that?
Yes.
Members, do you get that? Log?
Yes.
Log of 0.0052. For me, I'm seeing 2. I'm seeing 2 points.
Even me, teacher, I'm seeing 2 points.
You see?
How did you press? Let's go back. So we have 0 point.
Fiona.
We have 0.7, not so? 1, 6,
Yes.
0 minus 3, not so? Fiona, Fiona, stop lying to us, please.
Poison.
So it's supposed to be 2 bar, okay?
Yes, it is 2.
I've stopped trusting some of you now. So it's supposed to be 2 bar, okay? 2 bar,
Yes.
0.28, 3 what?
39.
39.
You can read all your these things. Logarithms of numbers between 0 to 1. Natural things.
Members,
Yes,
Yes,
teacher.
teacher.
any question?
No.
I think the question under exercise here.
Yes.
Pick any that is between, for numbers which are between 0 and 1, pick any and do it. Pick any and do it. Pick any and do it between 1 and 0. mix them up there. There we have numbers of more than 10, greater than 10, sorry. We have numbers of between 0 and 1. But I wanted to select only numbers between 0 and 1. Pick one and do them.
Can we send?
And send the answer. That is our C. I want to see whether people are going to select the right questions. Select for me the one which are between 0 and 1. Numbers which are between 0 and 1. Pick one. Just pick one and do it. You can write all of them, but just pick one and then you post me that answer. Post for me that answer. Okay?
Yes.
People have started running away.
No. People, no one is sending me the answer. No one is sending me the answer.
So we are going to send.
Yeah. You want to be smart, eh? Okay. Be smart and organized. Smart and what? Organized.
Organize.
Mathematics. Mathematician must be organized. That's our nature. Okay. Cynthia. Cynthia, that one for which number? Which number is that, Cynthia?
Number 3.
Number 3. That one is correct, Cynthia. That one is correct. Fiona, you did number 10. Number 10. Number 10. Fiona, that one is correct, but make sure that is to 4 decimal places, Fiona. Make sure that is to 4 decimal places. Okay?
Teacher, yes.
Wendy, which number is that, Wendy? Wendy, you did which number? Number 5. Wendy did number 5. Wendy did number 5. You people, you have got it. You have got it. Good. Clap for yourself. Clap for yourself. Good. I think we are together on that.
Yes.
So the characteristics and then the mantista, the argument, the what, those things, now you know them.
Yes.
So you must be, this one, we are still working on numbers which are to base 10. We are still using common logarithm. We are still using common what? Logarithm. But as time goes, we'll also see for other bases. We shall also see for other what? Other bases.
Yes.
Subheading anti-logarithm. Anti-logarithm. But this one. Let me just explain for you from there, okay?
Okay.
Now, members, anti-logarithm means I will give you the log. I will give you the log of a given number. Then you are to get that number. You get it?
Yes.
So you are moving backward. You are moving backward. So we call it anti-log. Is what? Anti what?
Anti-log.
Anti-log. If you remember, take for example, I have log, like for which number? Like if you say log, take for example, I'm having log to base 10 of 2.4. What is that answer? What's the log of that? Is what? Log of 2.4 is what? Is 0.3802. Okay?
Yes.
Yes. So now, this is the log. But if I want to get this number back, that process is called, you are getting what we call the anti-log. Are you together, members?
Yes.
You are getting what is called the what?
The anti-log.
The anti-log. So how do you get the anti-log? How do you get the anti-log? We can also use the table. We can also use the log table, but I've not put the table for anti-log here, okay? But from the calculator, from the what?
Calculator.
Using calculator. So I want to find the anti-log of what? Of this number, okay? Which number is this? We know that the answer must be what? Must be 2.4. Members, are you seeing that?
Yes.
So what you do, are you seeing shift here? Are you seeing shift?
Yes.
So if you want to get anti-log, you press shift and then log. I think what is displaying there? That one is meaning anti-log. That one means what? Anti-log. You press shift, then log. You press shift, then log. What you are getting there is 10 to the power something. That answer is what we call the anti-log. Okay?
Yes.
Take for example, I will press log of 2.4. Log of 2.4.
2.4.
The answer is what? Is that what the answer we get? Not so? But
Yes.
if I want to get 2.4 back, I press shift, then log, anti-log. Are you seeing that?
Yeah.
Have you seen it? Log 2.4. The answer is there, not so? Now I want to get that number back, that number. So that answer, I will press shift, log. Have you seen it?
Yes.
So which means from the table, you first read that, you go out to the table and you read for me log of 3 point, you read for me this value, 3802. From the table, you look for which number is close to this or exactly this. Which number is that? If you're getting that number must be 2.4. 2.4. That's what we call the anti-log. Right together?
Yes.
That process is what we call the what? The anti-log. Take for example, let's look at those examples there. Example A. Find the numbers whose logarithms are. So we have 0.1068. That's the log. So now we are looking for the number. Which number gave us this logarithm? So then we look for we read this logarithm. Members, are you together?
Yes.
Let's go back to our log table here. We have log of what? What is the log? Is 0.1068. So can we look for that logarithm here? From here, I think what I'm writing, not from the number. We are looking for the number, but before we get the number, we must look for the log. So can we read that number? 0.1. Where's 0.1? I think 0.1 somewhere.
Yes.
Where is it? This one is 0.14. Not so? But
Yes.
the one we have is 0.168.
68.
So I think 0.106.
No.
It's not there. It's not there, not so?
Yes.
Yes.
So what do we do? What do we do? What do we do?
And log.
What do we do? The number we want is the logarithm we want is 0.1068, not so?
Yes.
Let me show you from this table, because this one is giving us only to 3 decimal places, the one I'm using, okay? Let's use this table. Let's use this table. Let's use this table. I think this one here.
Yes.
Let's look for 0.1068. Let's look for that. There. 0.1, 0.1, 0.1, 0.1. Look for that. Look for
there.
It's not there.
But you are seeing, I think here, I'm seeing 0 point, I think where the cursor is
Yes.
is what? 0.1067. Not so?
Yes.
What should we add? We should add 0.01. Not so. We should add 1 to that. Not so?
Yes.
So what you do, you come and say 0.1068. Take away. What answer have you got there? On the table, we have got 0.1067. I think that. You subtract, this one will give us 1. So this is 0, this is 0, this is 0, this is 0. So we should add what?
1.
We should add 1. So you come to the column of add. Add or difference. I think it.
Yes.
What are we adding? We are adding 1. We are adding what?
1.
We are adding 1. But that number we have got is under which one? Is what? Is here, not so?
Yes.
That number is what? What is that number? The number is it? Go to the line of x. Go to the follow that log from the number of x. Is 0.0? 0.0 what? 0.02.
2.
Under what? Under what?
7.
Is under 8. Is under what?
Under 8.
Under 8. Then we are adding what? What are we adding? We are adding?
1.
We are adding 1. So that's the number. That's the number. Okay?
Yes.
Let's prove it. Let's prove it from our calculator. Let's prove it from our calculator. Now I'm going to get the log of this. So what is the log of 0.0281? What? 1. That's the number, not so?
Yes.
What do you get? We are getting negative 1 point.
Negative 1.519. 29.
So it's not giving us this one.
Yes.
So which means it's not the one. It's not the one. It's not the one. It's not the one. Because it must give us exactly this number. It must give us exactly this number. It must give us exactly this number. Let me check our table. Let's check our table when. Let's check our table. So let's check the table. Let's check the table. So log of 0. I think we are the one making mistake, please. We are the one making mistake. We are the one making the mistake. So we said, look for 0.10 on the column of X, added X. I think that. Move along
Yes.
that row until where it meets with the main column of added 6. Then the number at the intersection is, I think that is 1.276. Continue along that one, add what? Add 8. Add 8. Let's go back to here. Let's go back here. The log is, this is not anti-log. This is not anti-log. That's why he's giving us, we are finding it hard to get the answer, okay? Because this one is the not table for anti-log. Okay? Members, are we together?
Yes.
Yes, I've discovered. So that table we have is not for anti-log. It's not for anti-log. So what we can do from there, what is the more important is to know the steps. You should know the what? The steps. So you go to the table of anti-log. Table of what? Members, you go to the table of what? Anti-what?
Anti-log.
Anti-log. I'm going to let me look for one here. Let me just add it here. Anti-log. Then I show you. Anti-log. There we are. Let me get one from there. Let me get it in PDF. Members, have you seen it? Members, are you seeing that table?
Yes.
No.
Are you seeing it?
Yes.
Good. That's the table of anti-log.
Yes.
That's the table of anti-log. So now what we are going to do, we have the logarithm is 0.1068. Okay? So we are going to read 0.10. Okay? Under what? Under 6. Under what? Under 6. And then add what? Add what?
8.
Have you seen it?
Yes.
Are you seeing 0.1? Let's look for 0.1. 0.1. Are you seeing it is here? 0.1 is here. Have you seen it? 0.10. Have you seen it?
Yes.
Under what? Under 6. Under 6. Is here. Are you seeing it? Is here. Where the cursor is. Are you seeing where the cursor is?
Yes.
What is that number? What is that number? That is 1 point. Everything there is 1 point. So is 1 point. Is 1 point what? 276. Then we are adding what? 8. We are adding 8, not so?
Yes.
Follow that line there, follow that line until you see 8. What is that number?
2.
The number is 2. So which means it's going to be 0.002. Have you seen that? Plus. So when you add that one, we get 1.27 what?
278.
Like that. Have you seen it?
Yes.
Now let's press that one. What is the log? Log of 1.278. What do you get? Is not the one?
It's the one.
Is the one now. Have you seen that? You have seen.
Yes.
Yes.
Good. Good. Let's go back to our notes. Let's go back. That was A, B. B. We are finding 2.0088. Which number is that? So what are we going to do? We are going to read what? Read 2.00. Read what? Under what?
8.
Under 8. Then add what?
8.
Add 8. Let's go back to our logarithm. Is here. So let's look for 2. Let's look for 2. This one has ended here. This one has ended here. Is it ending in 0.2? Okay, 0.5. Okay.
Yes.
But at least you have got the concept, not so?
Yes.
Members, have you got the concept now?
Yes.
Okay. Okay. Or if it's like that, what we can do, remember, there's no log which is beyond 1. Because when you see what we can do, alternatively, members, I'm giving alternative, okay?
Yes.
Alternatively, because 2.0088. If you remember, I said this one is what? This is what? That is our characteristic, not so?
Yes.
Then this one is called what? Mantis what? Mantista. So to get this one is the same as 2 is adding 2 plus 0.0088. Have you seen that? Members, have you seen that?
Yes.
Yes.
Why am I doing that? I'm doing that because 2 is not in our table, but we can read 0.0088. Are you seeing that? Now, if you remember very well, so go back to your table. Let's go back to our table and read this one. Okay, let's go and read this one. Let's go back and read that one. What do you get? We have 0.00. Not so? 0.00 under what?
8.
Under 8. What is that? What is the answer? Is 1.02? To 1. What are we adding? We are adding 8. Not so?
Yes.
8 is what? Under 8 is what? Is 2. So which means when you add that one, what do you get? It becomes, when you add 2, when you add 0.002, what do you get? We shall come out with 1.02 what? Have you seen that?
Yes, teacher.
Have you seen that? Let's come back here.
Yes.
Let's come back here. Remember, our answer was this 2. This 2 is, how do we get that 2? How do we get that 2? So we are going to have 1.023, okay? Time is going to be time 10 to the power 2 now. Times 10 to the power what? 10 to the power 2. But this number here we have got is the log, which means it must be expressed to the power of 10. So which means it's going to be 10 to the power 1.023. Okay? Times 10 to the power what? Times 10 to the power 2. So now you can see that they have the same base. So it's going to be 10 to the power 2 plus 1.02 what? Members, are we still together?
Yes.
So we get 10 to the power what? 10 to the power what?
-4.
Hmm? What do you get? What do you get?
Teacher, you are still calculating. Ten to power 3.023.
But now remember that one is when you are getting the log. But our interest here is to get the what? The antilog. So when we are reading the antilog, we got the number was what? The number was
1.023.
So when you go ahead there you are finding the logarithm. We are not getting the antilog. That's why I wanted to show you this. So this one, don't again put it like this. Are you together, members?
Yes.
Yes, don't again put it like that. So what you do, because 2.0088, we got, it was 1.2 what?
2.3
times 10 to the power what?
negative
10 to the power 2. So that's the number. So what we do to simplify, we just say 1.023 times 10. This is what? That is 100, not so?
yes.
So what is that number? What is that number? So it's 1.23 exponent 2. What is that number, members? Is 100 what? 102 point?
3.
Point what? 0.3. So that's the number. Okay? So it means log to base 10 of 102.3 is the one which must give us 2.0088. Are you together, members? Are we together?
Yes, teacher.
Yes.
Yes. So can you prove that log of 102.3? You can see that. It's giving us that. It's giving us that. Okay? So any question, members? Any question? Read for me this one. Go and read for me this. Read for me this from your table. Read for me this. We have 1 bar point 0.769. This is the log. This one is the same as what? Is the same as? If you remember, it's the same as 0.0.079. What? 9. Plus, if you remember very well, plus what? Or you just say time. Just say time. Time 10 to the power negative what?
1.
Negative 1. So 0.0769 times 10 to the power negative what? 1. Go and get the antilog. Go and read for me this one. Go and read for me this. So you said you read what? Let me do that one very fast. Read 0.0 what?
7.
Under what?
6.
Under 6. Then add what?
9.
Let's go and check it very fast. Let's check that one very fast. 0.07. Are you seeing it?
Yes.
Is what? Again is what? Under what? Under 6. What is that? Is what? Is 1.191. 1.191. What are we adding? We are adding
6.
We are adding 9.
9.
We are adding 9. Which is what? Is what? Is 2. Not so?
It's 2. Yes.
So, which means if I add 2 to this, it will give me 1.19 what? If I add 2, it will give me 1 point because the same as we're adding plus 0.002. Are you together?
Yes.
So it will give me this. So which means the antilog of that number 1.076